All right, so in this section, we're going to look at limits at a point, identifying different characteristics of a graph of a rational equation, which a rational equation is something that has a numerator and a denominator. So the first thing we're going to look at is looking at a limit at an actual point. So the way we're going to do this is we're going to look at graphing this equation. So we have my y-intercept is at 1. I go up to over 1. So hoping that on the video you guys cannot hear my children screaming. Okay, so here is this. When I want the value of f of 3, normally what we would do with algebra is we would just plug it in. So we go f of 3 is equal to 2 times 3 plus 1, which is 7. Okay, so what I'm going to show you is that when I get really, really close to x equals 3 from both sides of x, so the left side of 3 and then the right side, so number is really, really close to 3 from both sides, that I'm getting closer actually to the number 7. So if I plug in 2.9 into my equation, so 2.9 into this equation, I would get 6.8. 2.99 into the equation gives me a 6.98 using a calculator, and then 6.998. I will never ask you to do this on a quiz or a test, so you won't need to worry about using a calculator. Okay, so 3.1 is actually a 7.2. 3.01 is a 7.02. And then a 3.001 is a 7.002. So as I get closer to 3 on both sides of the equation, I'm getting closer to 7. And that is really the definition of a limit, is when you go from the right side and the left side, what y value you're getting close to. Okay? So we then move along to looking at identifying limits. So if I'm going from the left side towards, and this should be -3. There's a typo there. From the left side, I'm looking at y is equal to -4. And then from the right-hand side, I'm going towards -3. And I get y is equal to 2. So the limit is always equal to a y value. Okay? And then the only way that I have an overall limit with no like exponent there is if these two numbers are the same. They are not the same, so this overall limit does not exist. Okay? So we look at exploring with a graphing calculator. And with the graphing calculator, you know, there's ways that we can look at what happens to your graph. Okay, so if I can actually factor this. So 2x plus 3 and an x minus 1. And then I can have an x plus 4 and an x minus 1. So now that I graph this, what you notice is that your x minus 1s would technically cancel out. Okay. Now when I graph this, I'm like, let's see what happens when I use Desmos. So I have 2x squared plus x minus 3. Then we're going to put this in parentheses. And then we're going to divide it by x squared plus 3x minus 4. Okay, so we will look at what you notice at x is equal to negative 4 is that you have like let's see if I can do x equals negative 4. You have this vertical asymptote. And what you notice at 1, if I go to 1 here, is that at 1, it was just there. It shows undefined. So there's actually open circle there, even though you can't actually see it. If we were to zoom in, you would see that at x is equal to 1, it is undefined. Okay, so what you do notice also is that at 1, it's really like 1 comma 1, like because I'm like just to the left of 1, and then I go just to the left of 1, and I'm almost at 1, just to the right of 1, and I'm almost at 1. So at 1 comma 1, there's actually what we call a removable discontinuity. Okay, so what do you notice at x equals 1? There's a removable discontinuity, meaning that there's an open coordinate point. And then there's a vertical asymptote, what we call a vertical asymptote, at x equals negative 4, because there's a vertical line where the graph gets very, very close to it, but it does not cross. Okay, so, and I just wrote that out there. So now what happens at 1,000, right? So we're looking at 100, 1,000, 10,000. So when I plug this into my calculator, right, and I can plug it into the simplified version, which is 2x plus 3 divided by x plus 4. Probably a little bit easier than actually plug it into that quadratic equation. So when I do that, when I do 100, I get 1.951. 1,000 is 1.995. And 10,000 is 1.999. That should have had a line there, and it should have been negative 10,000. So the negative 100 is 2.052, and then 2.005, and then 2.0005. So what you notice is that it looks like it's getting really, really close to 2. And if I pull back up my Desmos here, at y equals 2, looks like we've got a horizontal asymptote. If I zoom out a little bit, you'll see it's getting really, really close to it, but it's never actually crossing it. Okay, just a reminder about domain and range. Domain is values of the independent variable, so that's like x values. And then dependent variable would be y values in this case. Okay, so let's look at the vertical asymptote. Is going to be, if that's going to 1, then that's going to 2. And then my horizontal asymptote is y is equal to 0. Oops. So my domain is from negative infinity to 2, union 2 to infinity. And my range is negative infinity to 0. Oops. Union 0 to infinity. And that is it for this lesson.